Hi, everyone. My name is Aston Whiteling. I'm a senior product marketing manager at MuleSoft, part of Salesforce. And this is a talk I delivered at TDX 2024 entitled AI and Observability, the Future of Distributed Tracing. First up, we have to flash this up. The forward-looking statement essentially means, don't make purchase decisions based off anything in the roadmap. I'm going to be talking about some future things. Some of it's, stuff that's available now, some of it's more forward-looking, so just keep that in mind with everything I'm going to be discussing in this presentation. So this is the agenda. I'm going to start by saying what is distributed tracing, kind of define it, talk about why it's an important concept and technology in the world of health monitoring, talk about what problem it actually solves, go into a little bit of MuleSoft and Anypoint monitoring, and then the juicy stuff at the end, AI and the future of distributed tracing. So to start off with, what is distributed tracing? Hands up at this moment if you've heard of distributed tracing, and I would or wouldn't be surprised if you'd heard of it or you hadn't. I mean, it's a popular project within the Cloud Native Computing Foundation's portfolio, second only behind Kubernetes, which I'm sure everyone has heard of listening to this call, at least most people. But distributed tracing doesn't have as much industry mainstream adoption as something like Kubernetes. Why is that? I'll get into it a little bit later in this presentation. But to start, I'm defining what distributed tracing actually is. AWS put it well: distributed tracing is observing data requests as they flow through a distributed system. That's kind of the technical definition. I like to think about it in an analogy kind of sense, the analogy being a kind of plumbing, a pipe system. So imagine this is your network of your interconnected applications, and you're pumping data in. The data is the water flowing through this system. And then say something goes wrong with your e-commerce system, it blows up and you start looking at the metrics and logs. Something's wrong with that system, but not necessarily how you got there. Distributed tracing is kind of an answer to that. And to continue the analogy, it's like adding, dye to the water of your flow of data. And in doing so, you get that more holistic understanding of how data is moving across your application network. So that's the idea, that's the concept. In practice, it's kind of looks like that as well. So if you look at the left, you can see how the requests actually move through your system. So you have your user, and that is going from an application, and it's moving between, and kind of the trace is being appended as it moves between, as that request moves between those different systems. And if you move to the right, you can see the whole span of the trace, and then also its kind of child nodes, parent span of the application request and the child nodes, and that reflects the trace. So why is distributed tracing important as a concept? Well, it's because it's a kind of paradigm shift in how we think about monitoring and evaluating different monitoring situations. Essentially saying that the request is the unit of measure that you're using when you're evaluating the health of a particular application system. And this is actually more valuable than how we've been doing it traditionally, which is the events, things like metrics and logs, which are event-driven, and using that as a unit of measure. Why is that? Well, it's because it's closer to the end user's experience of interacting with an application network, and it's also interconnected. You can see the forest for the trees. You have that whole holistic understanding of how requests are moving across your application architecture. Whereas with events, it's kind of harder to see the forest for the trees. It's a bit more subjective. Things like metrics can mean different things to different people. Logs can weigh even more so. They're written by developers, and they're subjective, and in that sense, and then they're also disjointed. They're siloed into whatever application or a set of applications you're monitoring for metrics, and you don't get that holistic picture that requests and tracing affords you. So this is the reality. But despite this, in the modern world of monitoring and health observability, events are of course still prioritized. Metrics and logs are a much more prominent technology across the industry. Why is that? In part, of course, it's because metrics and logs have been around a lot longer than distributed tracing. So they're more embedded as a concept and a technology that people use. But this should probably change. And considering distributed tracing has been around since circa 2017, we haven't seen the adoption despite this inherent value from kind of pivoting and indexing around a request. Why is that? Now, personally, I blame Dora, and that's not Dora the Explorer, no. I blame Dora the DevOps Research and Assessment Group, even though I blame them, it's not really their fault. It's kind of how the industry reacted to something they kind of put out on the market. So I got a lot of hands up a moment, hands up if you've read Accelerate. Accelerate is the seminal work on the world of DevOps, written and authored by a few members of Dora. And this book, essentially the outcome of it for the DevOps world was to index around 4 different metrics to evaluate DevOps operability and health. And those 4 metrics being deployment frequency, lead time to change, time to restore, and change failure rate. So when this book came out, the industry loved it. I think the tech industry, especially in the metrics world, it's likes to take complex things like DevOps and then get frameworks like those postulated by the Accelerate and the Dora Research Group and orient really around them, because it's so simplifying and it's so powerful and easy. And I think because of that, the industry really took up this idea and this approach to metrics. The less metrics, the better. You only need to care about a certain set of metrics. When you think about it, when you take a metrics view, you scan your metrics across your application network, you're really just getting kind of a broad view of what's happening. You say this is maybe you become oriented around a goal or something, and then that's what you drive to using your metrics. The logs are the opposite. They're drilling into specific applications and you're getting a lot of depth because of it. You probably know where I'm going with this. With the trace view, you're getting the breadth and the depth, and that's why traces provide so much power. So what problems does distributed tracing actually solve? And this is a great quote from a wonderful Medium article that was a big inspiration for this talk from Samiyika on Medium. So I'd fully recommend you check out this Medium article and her as an author. And she says, ask any developer what the most painful moment in their life is. And they talk about times when debugging Seb1 errors in production with what seemed like a few hundred people breathing down your neck. And when that happens, when you have that few hundred people breathing down your neck, if you think about, the process of it now, when you're having 100 people breathe down your neck, at the moment, if something's going wrong in the logs, so the logs are spitting out a bunch of different errors, and then maybe you go, okay, let's check the metrics and see if we can find out what's happening there. And if it's the inverse and the metrics exploding, you say, okay, let's dive into the logs and see if we can isolate the individual application. So what's missing from this is, where do you necessarily start and who's actually responsible? And that's what distributed tracing actually changes. It shifts the paradigm for how we approach monitoring and health, and it does it because it changes that whole process. The first step now is to look at your trace data. That is step number 1, because you have that holistic, broad and deep view of the issues that are happening across your application architecture. From there, you then can determine with that holistic view the teams that are involved and the microservices that are affected that are causing the issue to happen. And then step 3 is kind of your normal process. You use your logs and metrics from there to drill into the issue, try and attempt a solution. So that's kind of the change to the start of the process, but you also, with distributed tracing, have this tail end where you can say, okay, we've stepped back, we've solved our issue. Was it more strategic? Was it more operational? And depending if, say, it was more strategic, you want that broad understanding. When you're doing a kind of retro, you can look at the metrics and orient your strategy around the metrics. But if it's more operational, you can dig into specific applications and craft your operational strategy using something like the logs. So this is the paradigm shift that tracing creates within the process of health monitoring and evaluation. And this is super important. And Daystar puts it well, because in microservice architectures, different teams may own different services that are involved in completing a request. And tracing makes it really clear, understanding where errors occurred and which teams are involved. And this is so important in the world of modern microservice architectures. And that's because microservices don't look like this anymore, like this network. Maybe if you're, day 2 of your startup, this is something it might look, your app network might look like, but they don't look this simple anymore. They look more like this. I took this graphic from The Register, who wrote an article about Monzo, a bank in the UK, and this is a visualization of their 1,600 different microservices that are interconnected. So when modern microservice architectures are looking more like this, getting this level of complex, for different businesses, is it any wonder that 73% of companies are reporting a mean time to restore greater than 1 hour? The mean time to restores are getting longer because these systems are becoming so complex and comprehensive. And distributed tracing is the antidote to this problem. So I've been waxing lyrical about distributed tracing, and you might ask yourself, why hasn't this technology seen a much wider adoption? And that's because there are a few barriers to entry with distributed tracing. It comes with its own challenges. First up is that, namely, if you want to prepare a network to pass a trace as it moves across, you can't do it in half measures. You can't just say, oh, we'll start with a couple of different applications. To truly get the most value out of distributed tracing, you have to configure your whole network to be able to pass that trace in order to get that holistic data. So that's the initial challenge, is having some kind of code agent that can go through and set up your different applications to pass that trace. So that's kind of barrier entry number one. Barrier entry number two is it can be quite hard to sort of sift through and understand the right context. Even though you have this holistic understanding, maybe you want to look at different logical entities or something, or search this data in a manageable way, that can be quite challenging with the complex trace data. And then finally, it can be hard to export. It's complicated. Tracing data is a complex data type, so because of that, it can be quite hard to get that trace data into a malleable state, so you can use it with your third-party observability ecosystem like Datadog, Dynatrace, Splunk, for example. So those are three issues, and wouldn't you know it, MuleSoft from Salesforce has just released a host of features for its Anypoint monitoring platform, Anypoint monitoring solution that provides a solution to these three issues. So that's what I'm talking about right now, Anypoint monitoring. The first up, distributed tracing. If you watched this talk, I don't need to dive into this one too much, but we've essentially configured our applications running in Cloud Hub 2 for the moment to pass these different traces as they move between your Cloud Hub applications that are deployed. And through doing that, you have a holistic understanding of the potential performance bottlenecks that are occurring across your application network in a visualized way. We have Anypoint Insights, which also was announced recently at TDX, on stage at TDX. Anypoint Insights is the ability to search through your monitoring and trace data just using a search bar and slice and dice it, so you can get that understanding of your holistic trace data, but from a more granular understanding as well via things like groups or entities or environments, also available for Cloud Hub 2. Then finally, telemetry exporter. This is a configuration wizard that lets you create an endpoint of your real-time telemetry data based on open telemetry standard. You can plug your Cloud Hub RTF data into your third-party monitoring tools like Splunk, like Datadog, and export that data in real time. So those are the three features: that Anypoint monitoring, distributed tracing, and Anypoint Insights are in open beta, and telemetry exporter is GA. Now we get to the juicy bit at the end, AI and the future of distributed tracing. How is AI impacting the world of observability? Again, forward-looking statement, fleshing it up for a second time. This is all kind of conceptual, what I'm talking about. It's not necessarily in the roadmap. This is, I guess, the thought leadership piece of the talk. So with AI, what problems will AI help solve when it comes to the realm of observability and monitoring? The first issue is the configuration issue. I talked about this a little bit in the previous segment. Essentially, it's a barrier to entry, and it's a challenge to set up a network to handle or to pin traces to the requests as they progress from different applications. You need some kind of code agent that will go through and set up your network so that it can pass those requests with the traces in order to get that holistic understanding. Even with an application network that looks like this, it will be quite challenging. So imagine if you have a microservice that looks kind of like Monzo's, setting up all these 1,600 microservices to pass traces as they move through, it can be quite challenging. There is already kind of a solution for this, and I spoke about it just recently in a few slides back, and that's distributed tracing for Cloud Hub 2.0, available via public beta today. If you run all your applications on Cloud Hub 2, MuleSoft does the hard part. We already set your applications up for distributed tracing. So this isn't even a barrier to entry if you're operating with all your apps running in Cloud Hub. Of course, we understand not everyone's going to be running every single application in Cloud Hub, so this can still represent a barrier to entry and a challenge for your wider application network outlay. There are solutions on the horizon, though. Even the cloud native or OpenTelemetry also has a tool available for this. It's kind of auto instrumentation tool that will go through and automatically, so essentially a no-code setup agent for complex microarchitectures that will automatically progress through your network and do the configuration with a very low lift. So this is it's still rudimentary, but it's developing, and this kind of automatic tool will be probably widespread and available, reducing that barrier to entry for everyone in the next couple of few years. Next up is the sampling issue. I didn't really talk about this so far, but distributed tracing across the industry, not just with MuleSoft, adopts the practice of sampling. So you have all your set of traces, you take your random sample. Of that random sample, industry standard best practices between 10 and 15%. Of that 10-15% sample, you look for the traces that are interesting to you, the ones where things are going wrong, and from that is what you actually examine when you're evaluating the health of your system. If you think about it, you want to take all the traces that you're capturing, you don't really care about the ones that are working fine, that have a good response rate, low latency, whatever. You don't really need to capture them. The only ones you really care about are the traces of interest, where things are going wrong, because those are the ones you want to evaluate to improve your system in some way. The problem is that when you have a complex microarchitecture like this, 1600, for example, taking all the traces of the requests that are moving through that system creates a huge data set, and that can be very hard to comb through. It's like finding a needle in a haystack. But what technology are we all becoming intimately familiar with that makes parsing large data sets relatively easy? Of course, I'm talking about LLMs. In the future, it will be possible that with using a Copilot LLM, you can actually use natural language to poll your trace data. And you can ask questions like, I want to see, or can you show me the request that had above average latency? And one of the great things, of course, about LLMs is the ability to build on your requests to kind of progress or build on your prompts in order to progress the data you're consuming. So you can build on top of that and say which of those requests, through errors or exceptions, and then you can find the conjoined, intersection between those two. So did any of those requests have empty or above average payloads, for example? So you can really get to the nitty-gritty using natural language. That's the power here, as well as combing through such a large data set. But you can use natural language to really get to the point and understand the problem that you're trying to parse with the health of your app network. Then next up, the trace enrichment issue. So at the moment, traces have not a huge amount of data attached to them, things like latency, exception, payload details. And this is because traces, as I said, are a fairly complex data type already. You're capturing a lot of data, so they can't have too many different fields. But with the rise of the ability to store huge data sets with things like LLMs, it's not unforeseeable that you could store a vast amount of additional data within these traces. So increase the data set, exponentially, but also get exponentially kind of increasing that value that you can comb through. So with that in mind, imagine a future world where you can automatically auto-instrument your entire application network, so it can just be ready to parse traces from the get-go with very little setup. From there, you get a huge payload of traces that have all the data you could ever want to understand, the runnings and the health of your application network. And then if something goes wrong, you can immediately use a Copilot to use natural language to comb through that trace data and understand your problem very, very quickly. With that in mind, this is essentially everything a developer needs to debug a software issue. And because of that, distributed tracing is poised to be the axis around which application network monitoring is built in the future moving forward. It's a really exciting time to get involved and start thinking about adopting distributed tracing. So why not start with MuleSoft from Salesforce? And with that, that concludes my talk today. I hope you enjoyed it. Thank you very much.